All right, let's get into it. We're going to go finish up our drawing here for the Mercedes-Benz Gullwing lobby. We're just working on that elliptical table right now. We've got our model pretty much complete. Only thing that we really haven't done is we have to add in that access panel at the base. So I need to pull that email back up from the other day so we can kind of dig into that one more time and make sure that we got an actual game plan together for where this goes and how we're going to attach it. So let me find that real fast on the side. I'll bring it up and then we can start looking at that. Once we've added the access panel, then the game plan really is going to be that we will be plotting this drawing. And then we'll talk about like what kind of views are necessary for something like this. It is furniture, so it does have a little bit more in-depth requirements than what you would see in standard cabinets or panels, because we do want to show more of what the framework is doing in the table. And so going back to that email here with Patrick, we're looking at the access panel specifically. So the other notes we've already kind of taken care of. We don't really need to worry too much about those, but the access panel itself is really important here. So oh, we already got all that taken care of. Okay, here we go. So again, the question was asked that the oval table on A406 has an access panel on its base. Is there only one access panel in this approximate location, or are there two on either side? Is there a specific location, or can we draw it roughly equivalent between the shortest radius and the longest? So response back was we only need one access panel here. Please locate it in the approximate location I'm showing below. You all can place it in the exact spot that works for you as long as it's in the general area we're showing. All right, so let's take a look at this a little bit more. What we're going to do is we're going to follow along with what they've got here. So it looks like really what they want is they want that access panel to kind of sit in the, if you're talking directions, like the southwest quadrant of the table. So let's go back to our CAD file here and then kind of look at the table that we have drawn right here. I kind of split screen between the email and our drawing here. Okay, so access panels. So we may not have really gotten into those yet. I'm going to pull up a block that you can kind of use as a reference to draw an access panel. This one will be slightly different. Generally, access panels and tables and desks and things like that, they usually what they are is a square or rectangular panel that has an 1/8 inch gap that goes all the way around that panel. And then the panel is typically mounted on, let's see, I'll pull up the detail here so you can see what that normally looks like. Yeah, because access panels are going to be slightly different in a case like this because this one isn't a large access panel. It's just really meant to show kind of the idea of like what it is that we're looking for. Really what it is like a small one. So we're probably going to end up using something like more like a button fix or a tensioner ball catch to attach that panel to the framing. The standard on-site access panel uses a combination of a few different items. So it might be a little hard to see because I'm going half screen here, but usually what we do is we'll sell them on a generic tab pull. So at the very top, you're going to see that hardware sitting up on top of that panel. There's the 1/8 inch gap that goes between your actual panel and the start of your access panel. And then the 1/8 inch gap at the bottom, again, between your access panel and the start of the panels or the trim below. You'll also notice that below that tab pull, there's a box that's sitting here. That is a magnetic catch. If you want to see one, I was going to hold one up if I have one in my box here. There's going to be one in the drawer at Loves Park. If you're at that location, you can pull that out of the drawer and actually do a hands-on show and tell sort of deal with that. If you need help finding it, just ask one of the team members and they'll help you figure out what that looks like so you could actually see one in person. If I can't find one here, what I'm going to do is I'm going to go online and actually pull a picture of one up so I can show you what it looks like. Please excuse me for just a sec. Okay, I may not have one here. That's all right. Here, I got an idea, at least. Um, so I might not have one here in my box, but I have something else though. So, all right. So let me pull one up online. I'll show you what it looks like so you can see it. Okay, so you've probably seen these before elsewhere in other, in the real world. These are just magnetic catches. They're used a lot on like cabinet doors if they're just I don't want to say like TV cabinets. I've seen them on there. Pretty much like knockdown furniture you'd buy at Walmart or something like that. You'll see these quite often. But that is a magnetic catch. So how it works is you have a metal plate that is magnetized and it's attached to the back of your door, or in this case, it'd be the back of our access panel. And then that's this guy here. And then you have the actual magnet itself, which is a rare earth magnet. And they usually have like a stack of them like this. They have a bracket that attaches it to either the sidewall of a cabinet for if you're using it for a cabinet application, or if you're using it for something like this, you would screw it into the sidewall of a rib inside of your framing. So that's a magnetic catch. And again, looking back at that, now if you look at this, you can kind of see what's happening there is that's the plate and the magnet sits here. So you're seeing it from like the top, but also the side, like looking at it face on, kind of like, oops, kind of like, let me pull that over there. So you're just seeing it kind of from the side over here. Won't let me switch over to that view, but you get the idea. So that's kind of what it looks like. It's a magnetic catch. If you haven't seen one before, most likely you probably have. Um, so that's holding the panel on at the top. At the bottom of your panel, we usually will use half of a Monarch Z clip. So we use the top half of a Monarch Z clip to attach that to a piece of blocking that sits at the bottom. So if you see one of these out in the shop or in our shop here, you'll 9 times out of 10 will see the construction of an access panel looking like this. They're kind of hard to see. If you look at a desk or something, you may see one, but it may be hard to see the hardware unless the back of the wall is unfinished. Then you might be able to see in there. If not, this is what really is looking, or what it'll look like on the inside of an access panel. So tab pull at the top, magnetic catch right below that, Z-clip at the very bottom. That kind of holds that thing on, locks it in place. The magnetic catch just holds it up, and then the tab pull makes it easy for somebody to lift and pull the panel off that desk. So in our case, we will have to do things a little bit differently because in our case, our access panel is in the base. So when I'm talking about for that, that means that like looking at our section view over here, let me go back to the top-down view. Looking at our section view over here, imagining this panel has to be removable. Now we could do part of it, we could do the full thing. It is small. I mean, looking at the dimension of it, it is only 6 inches tall from the floor to the bottom, or sorry, to the top of that trim piece. So really, a couple of ideal things that you can do. I'm going to move this over. I just want to see that you can see the hardware. So a couple things that we can do, as mentioned, there are hardwares such as this. This is a magnet, or sorry, this is not magnetic. This is a ball catch or a tensioner. Okay, it's hard to see. I'll pull one up online too so you can get a better idea of what it looks like. But these are a brass piece of material. There's two parts. So looking at it, you got a plate here and you got a base here. Inside of the base, it's hard to see a little bit, but there are two bearings that sit in there. And at the opposite sides of those bearings, there's a flathead screw. The flathead screw allows you to adjust the tension on those bearings that are inside of there. And then you have your plate piece, which mine's actually pretty bent up. It must have been around for a while. But you got your plate piece, which pops right into between those two bearings. All right, and you can use these like this, so you can mount a panel to a panel or a framework to a panel here. You can also use these at 90 degrees too. So let's say you had a panel that rounded a corner at 90 degrees. You can rotate that plate 90 degrees from the bearing plate, and that will allow you to attach something at 90 degrees too. This is kind of universal. It does do some pretty cool stuff, but we don't use these very often. It's just an example of a type of hardware that would work for a case like this. Let me pull one up online so you can actually see what it looks like, and then we will move on to what I think we should actually use for something like this. All right, so here's one here. This one's not brass, but it's the same exact thing. Um, see if it'll let me. Yeah, you can see the 3D view of it, which is a little bit more beneficial than what I was doing, trying to hold up the hardware there. So you can kind of see what it looks like. Um, it is literally just a plate at the top with two screw holes that has a unique shape to it that allows the bearings to grip it and hold it in place. You got your screws here, your Phillips, or sorry, flathead screws that help you adjust the attention on the bearings in the middle. You can kind of see them a little bit there. And then you got two countersunk screw holes on this plate, which are able to attach to either the frame or another panel or a substrate of some kind. So that's a really unique way you can use that. That is one specific hardware we could use in a case like that. The other hardware that I'm thinking about using, and I think this will be more beneficial to us, is using the button fix Type 2. This is a hardware which we have talked about a little bit during our cabinet training. We use them sometimes in microwave cabinets. We also use them to hold panels on or different things like that. We use button fixes for that typically. So it's a green circle, which is your the button, and then the fix, I guess, would be the plate. So really, these are designed so that they pop into place. The plate itself has two screw holes that allow you to screw that to framing or anything that you need, and then the um, green button is going to allow you to screw this into the side of something else. Um, so in a case like this, what we would probably do, um, and I'll kind of bring that up online too so you could see it a little better here. One sec. Okay. Okay, so a button fix Type 2 in real life, that's kind of what it would look like. They have an example of what it looks like they're holding a panel on. So you got the disc screwed or the button screwed to a panel, the plate screwed um, to a wall, panel, substrate of any kind. Well, that's cool. They have mending plates too. I don't know what that use would be for that, but that's kind of neat. They also have drawn diagrams of how these things look too. So really, those are a couple options we have here. I'm going to use the button fix Type 2 in this case just to be consistent with what we normally see on our drawings. So let's go back to our print. Okay, so button fixes are going to be in your hardware tool palette, and you're going to find those under attachment hardware. There's the Type 1, and you don't want to get those confused. They do different things. So Type 2 is the one we are looking for here. Okay. Now, when you go to use the Type 2, there's a drop down that's in there that allows you to switch it from plan to section to elevation. Really, what we're doing is we're going to, hold on, I might take that back. We can make that work. Yeah, we'll do it this way. Okay, so let's attach the plate to the back of our trim piece. So again, what I want to do is move this so that it's lined up with where it needs to go. Okay, and I'm going to lower this down a little bit, about a 1/4 inch or so. And I'm going to try to fit two of these in here. I would really love to be able to do that if I can. I'm going to move this one up a 1/4 inch too, just to be consistent. Again, I will not be dimensioning these on the print. They are just here to show the intention of how we're going to remove this plate or this piece of base trim here. So, and this only occurs on one side of our island. I would definitely recommend, to make things easier to be removable, that we probably want to lower this down 1/8 of an inch. And I think I'm also going to do the same thing for this here. I'm going to raise that up 1/8 of an inch in this guy as well. What I'm doing that for is to give it some play or wiggle room, so when you go to attach or remove this, there's going to be the ability to pry this off, and it shouldn't be too hard to do. So we're going to use that for now. So these are button fix type 2s again, and if you want to write that down, usually we'll use them for microwave cabs or for other items, but you can also use them for weird access panels like this that are a lot smaller. If you're doing a standard access panel, definitely use that block I was showing off earlier, this guy, because this one here is definitely going to be the standard when it comes to access panels. But we're kind of dealing with a custom product here, so this one's a little different. We need to use something different here for this. All right, so we've got the access panel drawn in this section view. We need to draw it in our elevation view too, and we can do that here in the model. I would like to do that in the model before we make our plots. That way it's going to be easier to really show what it looks like, because if you imagine trying to draw lines on a curved object isn't really going to be too accurate if you do it in 2D. So what I want to do is I want to break this panel up so that it fits between, I want it to fit between 2 ribs or 2 studs. And imagining we've got this quadrant here is what we're working with. What I want to do is kind of try to center this on that quadrant as best as I possibly can. It's going to be pretty difficult to do. So my plan is I want to select, let me see, how far are my ribs apart? If I went from one to the other, I got about 4 inches in between, or from center to center, I'm at 5 3/8. Okay, let's just verify to make sure they don't have a specified access panel dimension here on their drawings or in their email. If they do, we're going to try to match that to the best of our ability. If not, what I'm going to suggest is that we try to make that access panel probably between 18 to 24 inches wide. It has to be wide enough for somebody to be able to get in there and do the wiring. So 18 to 24 inches is probably a comfortable range for somebody to get their hands in there to be able to do that. So let's take a look at their drawings though first and just verify that there isn't a dimension already specified for the access panel. I'm going to pull this back up, so excuse me for just 1 second here. Okay, access panel is showcased here on their elevation view. Just says fully finished access panel located in base to access power coordinate location with owner / architect. Okay. All right, let's find out where we're going to put this thing. So right now, it's not really noted, and that's fine. So we'll make our best attempt at it. We're going to go back to our CAD file. Let me make this full screen again, and let's take a look at what we can do. Oops, I'm going to slice this too. I didn't realize I did not have the locator plate chopped. So I'm going to do that right now. All right, just like that. Sorry about that. I didn't catch that in the last video, so I want to make sure I did it now. Okay. All right. Okay, what I'm doing right now is I'm just trying to isolate the parts that are in this quadrant that we're going to be working with. So I probably don't need that. All right, so let's isolate just these parts. Again, I just realized I didn't have these sliced too, so I'm going to slice these two pieces here. And then I'm going to hide these. So hide objects. Okay, so this is the quadrant that our axis panel goes with. It's going to be somewhere over here. All right, so let's try to do the math and figure out like which of these ribs we want to use. So if I go, let's say we go between this rib and this rib, what is our axis panel like? It's like 17.5 inches, a little over. We could probably make that work. I think that's what I'll do. It's a little bit on the smaller side, but I think we'll make it work. So what I'm going to do now, so you can see what I'm doing, I'm slicing the base trim here. I'm going to run into a small problem, which I'll kind of explain how to get out of here in just a moment. So what I'm going to do is slice the base trim and the piece of substrate behind it here using the edge of my rib. So those 2 points there will be the slicing plane. I'm going to tell it I want to keep both sides because I don't want to delete anything. One thing that you'll notice is that although I did slice this part from this part, because these parts were all unioned together as one piece, now I have these parts over here separate. Well, they're attached, but they're not touching. So like you can see what's happening there. If you ever run into that problem, easy way to fix it is go ahead and go up to your solid editing toolbar up at the top. There's a command here called separate. So if you click separate, select the base trim, hit enter, enter, close out of the command, and then do the same for the substrate. You'll see now this is individual. It messed up my layers though, so I'm gonna use match properties to fix that. So I use match properties, correct that, match properties, correct that. And then what I would like to do is union these back together. So we're going to do that here. We're going to union those two pieces there, union those two pieces there. And then what I want to do next is find the next rib that I'm going to use as a slicing plane, which should be the inside of, I think it was this one. 1, 2, 3, 4. Oh no, I'm sorry, it was this one here. I was going to use this one here. So we're going to highlight those, the base trim and the substrate again. And I'm going to click this point and this point here. Use both to keep both sides. All right. And this one did not slice through that side, so that's great. And it's a check. That did not either. So what I'm doing to check, just so you know, if you highlight a solid object and hold down Shift in your middle mouse button, it will show you all parts attached to that object. So if you want to check something like that to make sure that it's not attached, you can do it that way. If you click on it, you'll also see that both of those parts get highlighted at the same time too. So kind of an easy way to check that. Let's go ahead and we're going to isolate these parts next. Come on, there we go. All right, and just like what we did in our section view, we need to have an 1/8 inch gap all the way around this access panel. So what we're going to do is we're going to use the press pull command. We're going to highlight the top of our substrate and bring it down, and we're going to type in 0.125 or 1/8 of an inch. We got to do that here as well. So come down here, 0.125, hit enter. And then we got to do that down below as well. So go up this time, 0.125. And then up again, 0.125. All right. Then the last thing we need to do is we need to add an 1/8 inch gap on the left and an 1/8 inch gap on the right. So let me bring everything back just for a moment so we can just verify that that worked. It looks like it did, so we're in good hands there. All right, so let's go back. We're going to isolate just those two parts, the substrate and the base trim that we're turning into an axis panel here. Isolate those two parts. All right. And then now I'm going to show you a cool trick you can do with the press pull command. So press pull, typically when you're working with a curved object, if you press pull on the edge of that curved object, it's going to make a straight object off of that. That won't really work for what we're doing here today. So what we need to do, instead of using the standard press pull, we're going to type in press pull again. And before we click on any faces, if you hold down the control key on your keyboard, you can bring this part in or out at a curved surface, which will follow the curve of the original part. Sometimes when you do this, you're going to type in 0.125, and we're going to check to see if it goes in or out. Whoops, hold on. I don't know what I just did. All right, let me do that again. So if you use this part of the command, sometimes it gets a little finicky. So I'll start with the back piece here, and I'm dragging my mouse to the right, which means I want to move everything that way. I'm going to go 0.125, and you can see instead of following the order or the direction I wanted it to go, it moved out 0.125 instead of in. So if it's giving you problems like that, just restart the command, hold down Control, select your face, and then as you type in your distance, try typing in negative 0.125. It will trick it into going the right way. So now it's going to go that direction, which is what we want it to do. We have to do that on this face and then these two faces still too. So we're going to use press pull again, Control, negative 0.125. And then we're going to do that again right over here, press pull, hold down Control, negative 0.125, press pull, hold down Control, select face, back, negative 0.125. All right. Now, if I unhide everything that I have here, I should be left with a panel that has an 1/8 inch gap all the way around, and it's going to sit right there. And it's going to look really weird in the model, but I promise you that like it will be absolutely fine. Like it's going to look fine in real life. It's just going to be a little weird if somebody's looking at it. They may be able to notice that it doesn't match up completely, but it's going to look all right. So since we have this now, let's go ahead and get into plotting mode. Okay, so let me check what time we've got here right now. We're at 27 minutes, 28 minutes. Okay, so we're good. All right, plotting mode for something like this. So you see my view cube's messed up too. Sometimes that'll happen if you're working in 3D. If your view cube is flipped over on its side, like it's facing the wrong direction, go down to this little drop down here where it says unnamed, and then you're going to hit WCS, which stands for World Coordinate System, which is the standard XY top-down view for AutoCAD. All right. Well, since we've got our model, and our model is actually pretty good, let's go ahead and save. Make sure we don't lose any progress that we just made today. We're going to highlight the model, and what I'm going to do is I'm going to go to my top-down view on my view cube, and then I'm going to use the flat shot command to start to produce some 2D drawings off of this. So we've kind of worked a little bit here in Flatshot before, just to recap though, so you have a kind of a sort of like a refresher on it here. We're going to change the foreground lines to by layer, the line type to by layer. We will be turning off the obscured lines. Out of habit, I set these to by layer usually too, but they don't show up. So obscured lines, as a reminder, if that is turned on, obscured lines is going to show anything that's underneath of anything that's underneath of our table here, which you really don't want to have. So what we're going to do is we're going to go to create. It's going to show us just a standard top-down view of our table, and we can drop that here roughly in the plan view area. Remember that when you do make a flat shot, it's going to ask you when you drop it in the model space what the X scale factor is, the Y scale factor, and the rotation angle. X scale factor is 1. Y scale factor is also 1. and rotation angle is going to be 0 100% of the time. So if you want to write those down until you get familiar with that, that is something that you're going to be typing in quite frequently when you're dealing with a 3D model and making flat shots. So after you've made your view, it's a good idea to use the explode command and then set all of your line work to be on the proper layer or here, or layers, depending on what you're drawing. So I need to go back to my layer properties to get to my 2D lines again. I'm going to switch back to my 2D filters, and I can close out of that. All right, let me highlight this, go to geometry, and then I'm going to open up properties one more time and just check it out to see, to make sure that my line weight is in fact set to by layer. For whatever reason, AutoCAD likes to set the line weight to 0 millimeters when you do make a flat shot, which doesn't really work out very well when it comes to actually trying to make a drawing, because if you print that drawing out on paper, it's going to make it so light that you can't even see what you're looking at. So you want to make sure that all your lines are set to by layer for line weight. It's going to make sure that everything is the proper thickness for line weights. So let's move on to our other views. So we need at least 3 elevation views. Normally, in a case like this, 2 would be sufficient. Like what the architect had drawn, they had about, I mean, they didn't really have 2 elevations, but they kind of did. So like really, we really want to see an elevation view of the side with the access panel. We want one with the side without that access panel. And then we want one of the short side of the table. So kind of like looking at this side of that table. So let's go ahead and make those. All right, so let's do our flat shot here, looking at the side of our table, and make sure that again, by layer, obscured lines is off, and by layer, you can hit create. And then I had to hold down shift and my middle mouse button to rotate my view again, but I'm going to drop that somewhere over here for now. X scale factor 1, Y scale factor 1, rotation angle 0. And this time around, what I'm going to do is make all my elevation views and then explode them, check out my line weights, and kind of work around it that way. So flat shot, again. And I'll probably make one of each side, so like all 4 sides will probably get an elevation view here, because I want to make sure that like I am showing everything as thoroughly as I possibly can, especially because I spent a lot of time making an actual 3D model of it. I wanted to show everything that we're doing. Here we go. And we'll do one more flat shot of this side. Just make sure that you're lined up. Using your view cube is a good technique to be able to line things up just perfect, straight on the side of your drawing. Once you make your view, hold down shift middle mouse, and we're going to bring it on over here. 1, 1, and 0 again. And then we're going to line all of these up, explode them, and set everything to by layer. So let's get all of our views lined up with the grid. Okay. And then we are going to then move all of these over. And I kind of like to, when I have multiple views for each category, like in this case, elevation view has 4 views. What I like to do is space them either 150 inches or 300 inches away from one another. That way, when I'm putting dimensions or adding material calls or hardware calls to my views, there's a lot of extra margin room in between these views. If I start with 150 and that looks sufficient, then I'm going to keep that as a standard here for this print. And 150 definitely seems like it's going to be perfect for this. That's not a number you have to hold to or have to remember. It's just something that I do because, again, if I am drawing a print like this with multiple views in one grid space, I want to make sure they have enough spacing in between for dimensions and everything so they don't run into each other. All right, I just exploded those, set everything to by layer, and now we're going to move on to, well, before we get to sections, hold on, I forgot one thing. We want an axial view of our table to show off how cool this looks. Well, really, that's not the real reason, but we want an axial view to show a preview of what this looks like. So typically what you can do, standard axial view, what you'd want to do is pick a corner of your view cube, and you're going to use that to flat shot and make a axial view of your model. If you want to take it a step further, you are more than welcome to. If you type in perspective on your keyboard and type in 1 instead of 0, what this will do is it will put AutoCAD in a 2-point perspective view. And what that does, sorry, I'm trying to get lined up with my model. What that does is as you get close to your model, you'll see that it starts to, it's not really distorting it necessarily, but it's making it show more of a perspective type of line drawing versus a standard axial view. Sometimes it helps to do this. It's kind of more of a flair, like show off type thing. But if you want to go the extra mile and do this, I highly recommend it because it does look a lot nicer. Sometimes when you turn on perspective, you'll notice that your flat shot is a lot larger than what it should be. And that's okay for an axial view because we're not actually drawing this to scale anyway. But what I'm going to do is drop this up here, set my X scale factor to 1, my Y scale factor to 1, my rotation angle to 0. Then before I finish out this thing, what I'm going to do is go perspective again and type in 0 this time to turn it off. So we'll go back to a normal sort of view. You'll be able to tell right away if you're in perspective mode because the background turns into a gray gradient scale type of look. And sometimes you can accidentally get yourself into perspective mode. If you do, don't worry too much. You can just go ahead and type in perspective and then 0, and it'll fix it for you. I'm trying to shrink this down a little bit so that it actually looks more representative of what our table is supposed to look like. And then what I'm going to do is line this up to the best of my ability with the grid that we have here. Explode that view just like normal. Go in here, change it to geometry, and make sure that all my settings are set to by layer again. So line weights are set to by layer here. Okay, now we've got the axial view, the plan view, the elevation views, we are going to be making our section views next. So with a desk like this, what I would like to do is isolate just the 3D model. So I'm just kind of looking at this right now. All right. We're going to be making a section plane to cut through this. And before we do, again, I'm going to save real quick just to be making sure that I don't lose any progress. It's kind of paranoia, kind of just out of habit, but try to make sure that you save after any big change that you make so that way you don't lose anything by mistake. There's ways to get things back if you don't, but you really don't want to risk it. So, all right, moving on though. Oops, whoa, hello. Moving on though, let's see, we're at 39 minutes. Let's go ahead and make our section views. We could probably start putting things on paper and then we'll dimension and tag it in the next video probably. So let's go ahead and keep moving. All right. So section planes. Again, those are accessible through your 3D toolbar. So if you're not on there, go down to your settings gear at the bottom, change to 3D modeling, and then you'll see this up here. So section plane is a real quick way to generate a section view off of a model. I think previously I did show you there's another way to do this too. If you copy your model off to the side and you slice it and erase half of it, you can make a section off of your model that way as well. Both are perfectly acceptable. There's no wrong way to do it. I only like using section plane because although there are more settings to set at the beginning, it helps you with plotting it later. So the hatching part becomes much more efficient later if you use it this way versus using the slice and then have to hatch every little piece later. So let's go ahead and make a section plane. And we're going to make this through the, whoops, hold on, let me redo that. Come on, a section plane. And what I want to do is make it through the middle of our table here. Okay, so kind of trying to draw this in. Sometimes if you click on a point on your model, it will automatically place it. I really don't want it to do that. So as you see, what I did there is I kind of used the midpoint of my model, hovered my mouse over it for a few seconds, and then moved my cursor backwards like this. So I use that as my first point, and my second point is going to be somewhere out in space like this. It can be anywhere. All right. Now that I've got that, though, you can see slicing directly through the model, what we're going to be able to see is we're going to be able to see this half of it in that section cut, which is fine. That's actually what we want. So what we're going to do is we're going to click on that section plane again, go up to generate section block, then generate section block again. Don't know why it's on there twice. So we'll go through there. Again, if this is your first time making a section, you are going to see this menu pop up like this. Rather, though, you want to be on this caret here, which is going to give you the additional section settings at the bottom. So you're going to click on that. And then over here, you're going to want to set these up just like we have been doing. So again, make sure that we'll go one by one here. I'll close these out for a minute. That way it's easier to follow along. So intersection boundary, that is anywhere that section plane is cutting through your model. So all that gray stuff you see there, that'll end up being the intersection fill, but the intersection boundary are the outlines of what I'm cutting through. So that's going to be set to by layer. The layer will be geometry. The line type will be by layer, and then line weight, of course, will be by layer too. Once you have these set, go ahead and close that out. We'll move on to intersection fill. Intersection fill, we're going to say yes to that. It's already on solid, so we're good there. Let's change the color of that to by layer, the layer to hatch, and make sure that your line type is set to by layer as well. Once you change those few things, we're going to move on to the next. So I'll pause here for just a quick sec and then we'll move on. All right, here we go. Background lines. Background lines again, that's anything in the background that your section plane is not cutting through, but you still want to be able to see it. So all these ribs that are back here, all the framing, all the back of our panel, we do want to be able to see that. So we're going to go here. We're going to say we do want to see those, so yes. Hidden lines, we're going to say no to, though. What that would be is if I had hidden lines turned on, you're going to see things that are beyond, that are not actually visible right now. So like if I cut through my section here, and these ribs here on the backside are completely solid, what would happen if I had hidden lines turned on is I would see like these stripes of this blocking through those ribs, and it's going to get very muddy very quickly. So we don't want to show hidden lines for that. So we're going to turn that off. We're going to say color is, of course, by layer, of course. Layer is set to geometry. Line type is by layer, and that's all we need there. So no hidden lines, by layer, geometry, by layer. Once you've got that, go ahead and minimize that, and we're going to move on to cutaway geometry. So cutaway geometry, we're going to say no to hidden lines and no to showing these, and that's all you need to change. We are not going to show any of this, so we don't need any of those. Curve tangency is in the same boat. You're going to say no to curve tangency lines, and that's all you need to change. All right, I'll open these back up. Once you've got all of these settings set to where you need them, you can hit OK. And then we're going to hit create. Sometimes it will take a minute depending on how complicated your model is, but if you go ahead and save this off to the side, you're going to see a very similar set of questions: X scale factor, Y scale factor, and rotation angle. So we know that is 1 for the X, 1 for the Y, and 0 for the rotation there. So now that we've got that, let's go ahead and try to make a section view through the other side of the model here. So we're going to 3D rotate the section plane, just like that. And then what I'm going to do is move the section plane using the move command, and I'm going to line it up with, if I can get it to snap, to the end of my table here, which isn't quite spot on. I got to do some adjusting here. It looks like I didn't quite get it. So there we go. There we go. Now that we've got that, let's go ahead and make another section off of this. So we're going to go to generate section block, and once you set all of your settings the first time, you don't have to do it again. So you can just hit create this time without doing all of those complicated things there. You can hit create and then go ahead and do the same thing, paste it off to the side, X scale factor 1, Y scale factor 1, rotation angle 0. All right, so we've got a section through the short side, a section through the long side. Now let's go ahead and we're going to make a couple of horizontal sections here too. All right, so to do this, we need to rotate our section plane, and we're going to use 3D rotate here. Highlight that section plane, make sure to grab the correct plane to rotate around. We're going to use the red plane or the X plane here, and we're going to rotate this 90 degrees. So this can be a little tricky, just being able to find what you're looking at. So like in this case, I believe I'm looking at the correct side. If you do need to flip your section plane over, you can either rotate it 180 degrees, or there's a little arrow right here that allows you to be able to flip that. Now, I think I'm good. What I'm going to do is I'm going to, let me flip it just to show you what it does. So now I'm looking upward, up at the underside of my table, which generally sections like horizontal sections, you're going to want to go facing towards the floor. So keep that in mind as you're drawing horizontal sections, that you always want to be looking at the floor, not at the ceiling. So we're making a section view looking at the floor here. Let's go ahead and hit create and paste this over here. So 1, 1, 0. All right, and then we need one more horizontal cut through of our little table / island here. And that's going to go through this. I want to show how these ribs look in here. And the only way to possibly do that is to make a horizontal section through that. So we're going to do that here. We're going to generate section block. And then we're going to hit create right here. All right, so 1, 1, 0. Now that we're done with all of our sections, this section plane is no longer needed. We can actually just delete that thing, and we're done with it. So let's go back to our top-down view. All right, and then we are going to also switch back from conceptual to 2D wireframe. This is a really critical step that you want to follow. If you don't do this, your computer will get extremely slow. And I'm giving you the warning now, so that way you don't fall into that trap. If you are working in 3D, you can use conceptual, realistic, shaded with edges all day long. The second you start working in 2D, if you have it on conceptual or any of those other 3D views, what'll happen is your dimensions will start to look weird, and they might start disappearing and reappearing, and you're also going to have a little bit of a harder time zooming in and out and panning across your drawing, because those views are specifically designed for 3D viewing purposes only, really. And if you're trying to view 2D objects with one of those views, it gets really clunky really fast. So if you're trying to work in 2D, make sure that you're always working in 2D wireframe. If you're working in 3D, you can work in wireframe if you'd like, but these are also available to you too. Just a fair warning. All right. Oh, I forgot. I got to unhide all of my grid. So I'm going to do that next. Let's unhide the grid. And we're going to move all of our section views down to here. All right. And then what I'm doing right now is I'm just doing the same exact steps that I've been doing, putting my view down in the grid, moving it over 150, and then I'm going to explode these views and make sure that everything is set to by layer, including the line weight specifically. All right, here we go. Here we go. Okay. All right. Let's go ahead and get in the next step. So explode these, highlight all of our views, make sure that everything here is set to by layer. It looks like we're good on that. Layer is saying varies, and that's because I have a combination of hatch and geometry applied to these layers, and that's all right. That's just what it is. So next up, really what it comes down to is hatching these views. Sorry, I just noticed something goofy too. If you see something like this where you're getting choppy lines and it looks like PlayStation 1 graphics, probably just dated myself there. Just type in regen, and it's going to refresh AutoCAD to show you the accurate line curves and everything. If you're zooming in and out a lot in AutoCAD, sometimes it will get buggy and it will start to make your lines look more segmented or choppy. I'm just doing it right now to see if it'll work. You can kind of see a little bit, but if I type in regen, usually what it'll do is it'll kind of smooth those out and fix them. It won't affect your drawing at all because as you plot the drawing, it regens it automatically anyway. But it's something to keep in mind too. If you're seeing that and it's bugging you, just type in regen. It will refresh AutoCAD and also bring in the correct curves instead of segment there. All right. So next up, as promised, we're going to be looking at hatching. And we are at 52 minutes, so we'll probably save the plotting part for the next video altogether. But when you go to hatch, because you've already got the solid hatching in here, all you need to do is find the correct hatch in your hatching tool palette. So just click on a hatch and then scroll down to where you're going. So there is my plywood hatch. That's for my subtop. We're going to use match properties and we're going to color by number and start to fill in the rest of these here. So Dye-Wall Framework is completely made up of plywood. So if you're hatching all of your plywood, you can do that right now. Let's go and do that on all of our views. So all the horizontal plywood, let's hatch all that. See, must have a double layer of something there. So I've got 2 layers of hatching going on, which is a little weird, but we'll make it work. Generally, you are not going to be hatching your ribs. So let's remove that. That's not something you're going to want to do. So don't hatch your ribs, just the parts that you're really cutting through. So that would be really confusing to see. So let's not do that. Let's see, what else do we need? Well, we can do our vertical plywood. So vertical plywood is going to be super easy. It's the same hatch. It's called Dolmet. Dolmet's right here. We're going to rotate that 90 degrees like this. And then we're going to use our match properties to apply that to the other areas that require that plywood hatch, the vertical plywood hatch specifically. Do, do, do. Oh, come on. Okay. Oh, I almost forgot. I got a couple more to do down here. There we go. There we go. Okay, sweet. Very nice. Again, this is a rib here. We're not going to hatch that. We're just going to erase that hatching there. Okay, so next up, let's look at our countertop. Making sure that we're being consistent with our tool palette. We want to make sure that we are using the correct hatch for that. So back to the drawing. The material for the countertop is a QSO2, which is a quartz material, which does fall into the realm of stone and solid surface, meaning that when we go to hatch this, we're going to be using that same hatching that we use for stone and solid surface. If I go to our tool palette in the hatch up here, that exact hatching that you see in your tool palette is AR concrete. Uh, so that's what that is. Typically, what we'll do is we'll reduce it down to a hatch scale of 1/8 of an inch. So your hatch scale 0.125. And then you can take your match properties and you can start applying this to all areas that have that material. Okay, which I think that's it. That is it. Okay, sweet. We got some vertical areas here. These are being clad with that MTL1 or MTO1, which is our ML1, which is a laminate. We also have PL1 laminate down below. So anything with those two calls and the green highlights here are going to have the MDF hatch. Okay, so our MDF hatch is the dashed one that you see here. So if you click on a hatch in your CAD file, the equivalent hatch to that is literally called dash. You just got to make sure that it's set to the right angle. So 90 to make it vertical, 0 to make it flat. And I'm just going around and applying that to all the areas that need that vertical MDF hatch right now. Okay, now that that's done, we're going to apply that to here, but we're going to rotate this hatch to be flat, so 0 degrees for that. Okay, that needs to be everywhere, including there. Okay, so hatching wise, we don't have any more solid hatches in here, so we are actually really good. We've got it all figured out. Nothing else to worry about there. All right. Last thing you can do is you can throw in your floor hatch for all of these drawings. So we're at 58 minutes, so I'll probably conclude after that, and then we'll go into putting everything on paper at the end after that. There we go. There we go. Okay. Oh yeah, I didn't hatch these yet. I guess I could do that real quick before we end it. So this is dashed. This is plywood, which will be Dolmet. Luckily, they're in alphabetical order, so that does make things easier. Because it does curve, right now I'm not really able to do much about that, so I'm going to leave it as best as I possibly can. If I rotate it at 90, it probably wouldn't look very good, so I'm going to leave it flat like I have it here. Then we'll apply that Dolmet hatch to all of our ribs. Same deal for these two. Theoretically, what I would like to do is I would like to rotate these to match up with the angle roughly about like where they're placed. It would be kind of time consuming, but it is possible. I will try to do that here. It's going to take a little bit of time to do so, but I'll show you how you can do it though in just a moment. Okay, and then these here will be dash or MDF hatch. So we'll do that here. Okay. Oh, forgot that spline right there. Boop. Okay. Hey, so let's rotate these hatches around. So what I usually do, you can see what I'm doing here, is I have this little slider up here. It allows you to change the angle of those ribs. And what you want to do is kind of make your way around. If you want it to be precise and to look right, you do want these to be as close to parallel with your rib lines as you possibly can. You may not always be able to get it 100% perfect, especially when you're dealing with a weird curve like this, but you can get it pretty close. All right, just making my way around. Like I said, this is a more time-consuming step. Um, there we go. It is a little more time-consuming, but we'll get through it, though. It's a little bit of extra work to make it look a little prettier. Once you've done all this, though, then the next step, of course, will be plotting the drawing, which is the final step pretty much, or series of steps, I suppose I should say, because that is a series of steps. And that'll be kind of very familiar to you with what we've been doing, with cabinets and panels. Plotting is going to be pretty consistently almost the same sequence of steps every time you do a drawing, no matter what it is. Some drawings are going to have like some other areas that you need to highlight or detail more, and that's fine. Like furniture, of course, you're seeing that already. There's already other things here that you need to add into it. Like these horizontal sections, of course, are going to be more things that are more pertinent, like to things that you need to add just to show more detail. Without these, it would be hard to be able to know how we plan on actually framing this out. I think I forgot to add one die wall too, so maybe I'll try to add that in real fast before we call it. The die wall that's in the middle, that flat one, the really basic one. But I'll show you how to use a block to draw that in, so that way it'll be fast and easy. Unfortunately, the curved ones, you can't really do that, so. There we go. Almost there. Hang tight. I don't really like this one. I'm going to try to adjust it a tad bit more. That's a little better. Okay, now we're looking pretty good. Now if you zoom out a bit, I mean, yeah, maybe not all of them are 100% perfect, but it does look a lot better than just hatching it generically with just all of them going vertical, even though that wouldn't really be how it would look. All right, so last step here. Promise you this is the last one for this video. I did want to include a middle die wall here in the center, similar to what they had drawn in their section view here. This will be to carry the load of the weight of the middle of the table to help support that. And when we do that, what you can do is we do have some standard die wall areas that you can add to your drawing nowadays. I did kind of briefly look at them earlier with you, but there are vertical sections and then there's horizontal sections that you can add to your print. We'll add a horizontal section of a die wall here in the middle when it loads. These are more complicated blocks, so they do take a little bit of time for them to actually populate. What I would like to do is maybe make it, let's see what it's going to look best. Let's start with making this like 4 feet wide, 48 inches, and see what that does. And I'm going to place it dead center of the table. Jeez Louise, people won't leave me alone. All right, so what we're going to do then is we're going to leave that there. So we got our middle die wall, we got our wraparound edge die wall that sits there. And then probably another good idea would be to add that into our section here. So like to show that, what you can do is grab the vertical blank die wall section that's here. And we can drop that into our vertical section through the middle of our table. And then what we're going to do is we're going to first make sure this is right in the right height. And then we got to trim everything to the outside of that. So what I'm doing right now, as you can see, I'm going to hide these items, and then I'm going to trim everything that's being inside of this red rectangle. So I don't need to see these. These would be like your hidden lines, your invisible lines that we talked about earlier, ones that you typically don't want to see. Let's remove those. And we can trim these lines back to here. So just trimming them back to there. Once we've done that, I'm going to erase this red rectangle that I have drawn and then unhide that middle die wall that we had drawn in. So just like that. Easy enough. All right, so that is pretty much that. As far as the section views that are required for a piece of furniture, the elevation views and plan view, of course, and your axial view of your furniture. That's pretty much what will be required here. And so right now, I'm going to leave it off right here. In the next video, we will be getting into a couple of other areas where we need to add in, well, we need to add in our viewports, of course, and then start plotting everything out on paper. And I think we could probably knock all that out in one video, but I'm going to save it here, and then we'll get into that in the next one.